This lecture is the second part of writing and balancing equations. The first lecture you learned just about the basic parts of an equation, but now what we're going to do is we're going to learn how to write these equations and also how to balance them on both sides. So in order to balance an equation, what we're looking for is for the number of atoms in the reactants, so what we're starting with, to equal the number of atoms in the products. So what you need to think of is everything that we put in, we must get out in an equal number. It might be rearranged, it might look different, but we always have to have the same number of atoms in the reactants as we do in the products. So the first thing that we have to do is determine the correct formula for the reactants and the products. Sometimes you will be given equations that are already written in their formula form. Sometimes you're going to be given those equations in word form. We're going to work through word problems at the end of this lecture, but the first thing that you have to do is determine the correct formula if it is not already given to you. Then you're going to write the equation if it is not already written for you. And then this is the thing that you're going to do each time, no matter if you're given the equation or not. So the first thing you're going to do is count the number of atoms of each element on each side of the equation. So you're going to count the number of oxygens on the reactant side, count the number of oxygens on the reactants. Count the number of sulfurs, count the number of sulfurs. So you count how many are on the reactants, and you count how many are on the products. You do not combine them together, you count them separately. If you have a polyatomic ion that stays the same from reactants to products, so it's a sulfate in your reactants and it stays sulfates on the products, you're going to count that together. So you're going to count this as sulfates right here. That should be a subscript on that 4. You're going to count it as 1 sulfate and 1 sulfate instead of counting 1 sulfur and 4 oxygens. So you balance your elements one at a time by using coefficients. You were introduced to coefficients in the last video, but just to remind you, these numbers right here are subscripts, the 2 and the 3. They are not coefficients. A coefficient would be if I put a 2 in front of that O2. This would be your coefficient, okay? So with that being said, you never, ever, 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 ever change the subscripts. So if we need 4 oxygens, let's say on one side, we cannot change this to be O4, okay? Because if you think back to when we did naming, the reason that it was a 2 has to do with balancing out your charges if it's ionic, how many there are, if it's covalent. So we can't just go changing the subscripts. We have to add coefficients in front to change how many of an atom we have. Another tip is you want to save your hydrogens and oxygens for last. They tend to show up in a lot of different situations. So count your other things. Count your nitrogens, count your carbons, count your sulfurs, count your fluorines. Save your hydrogens and your oxygens for last, okay? It will make your life easier as you continue to balance equations. At the end, you want to double check each atom and polyatomic ion to make sure that it's balanced. Don't just assume that you did it correctly the first time, okay? Go back and double check yourself. And then you want to make sure your coefficients are in the lowest number ratio. So that's just kind of having, like if you are reducing your fraction, so you have, let's say, 2/4, you would reduce that to 1/2, okay? That's what we're looking for. We're looking for the lowest ratio that we can have with our elements. All right, so let's do some practice problems here. So this helps some people. It doesn't help others. If this helps you, go for it. So we had our reactants over here with the zinc and the hydrochloric acid. And then we have zinc chloride. And then we also have hydrogen gas. So one thing I need to change here is this should be a 2 because zinc is +2. So that should be zinc plus HCl plus ZnCl2, which is zinc chloride plus hydrogen gas. Okay? So first thing I want to do is count how many of each thing I have on each side. So I have zincs on this side, I have 1. If there is no Subscript here, you have one of that element, okay? H's, I have one. In chlorines, I have one. Moving on to our next side. On our products, remember these are your reactants, these are your products. Reactants over here, zincs, I have one. I like to keep them in order, so I did H next here. So H's, I have two. And then chlorines, I have two. That's where I added that subscript there in that chlorine. Okay? So, my zincs are equal. Okay, so that's great. One zinc on each side, ready to go. Hydrogens, not equal. Chlorines, not equal. So what I'm going to do, I'm going to save my hydrogens for last. I'm going to change something to make my chlorines equal. Now remember, I cannot change this value right here. I have to keep that the same. So this is going to be 2. But what I can change is the value of this 1. The way that I do that is I put a 2 in front of here. So now I don't have 1 chlorine, I have 2. Because what happens, and this is very similar to what would happen if something were in parentheses, this coefficient, it distributes to everything inside of your, or in that compound. So I have 2 chlorines now, but what else do I have 2 of? I have 2 hydrogens now. All right, so now let's go back and check. 1 zinc, 1 zinc. 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. So everything's done. Everything's balanced. I have the same number of atoms of each thing on each side of my equation. Now, what we have to think about is what goes in this spot here. If there is nothing there, you can leave it blank. You do not have to fill it in, but if it makes you comfortable that something's filled in there, you're just going to fill it in with a 1. That's kind of up to you though. Right, so that one kind of easy. We'll go on to another one. Aluminum plus oxygen gives us aluminum oxide. So if this helps you, go ahead and draw an arrow down, or a line down the middle between your reactants and your products. Aluminums on this side, I have 1. Aluminums on this side, I have, that subscript tells me how many, I have 2. Oxygens on this side, subscript tells me that I have 2. Oxygens on this side, subscript tells me I have 3. Alright, so how many aluminums do I have on this side? I have 2. This side I have 1. So I'm going to have to change something with this side here. So to make that equal, I'm going to put a 2 right here. So now I have 2 aluminums. Also, you might want to use pencil with these. I'm sorry, I should have said that at the beginning. Using pencil on these because you might be changing some stuff as you go. So now I have 2 aluminums, 2 aluminums. On this side I have 2 oxygens, and this side I have 3. So it's not one of those things where I can just change what I have with one of them, because with this aluminum, I could multiply this by 2 to give me 2, this side. But there's nothing I can multiply 2 by to give me 3. So I'm going to have to change something on both of them. So this goes back to finding a least common multiple. My least common multiple between 2 and 3 is 6. So what I'm going to do is I'm going to multiply this oxygen by 3 to give me 6 oxygens. Then what I'm going to do is I'm going to multiply this oxygen on my product side by 2 to give me 6 oxygens. So great, oxygens check out. You might want to stop there and say, okay, we're good to go. Everything's balanced. But what we have to remember is that when we put this 2 here as a coefficient, it also applies to the aluminum. So now on this side, I don't have 2 aluminums anymore. Now I have 4. And now I'm not equal again. So now I have to go back to my reactant side, and I have to change my aluminums again. So I'm going to change this also to a 4. So see why sometimes you want to use pencil, because it's not always the first time you do it. So now I have 4 aluminums on this side. Let's just double check everything. 4 aluminums, 4 aluminums, 6 oxygens, 6 oxygens. All right, everything's equal. So just a reminder, when you are looking at your coefficient and your subscript here, you are multiplying them. They are not being added together. Okay, so it's multiplying. It's just like the distributive property. If something were outside of your parentheses, you will multiply that by everything within. All right, so we have another one here. So if you want to draw that line, if that helps you, we'll go ahead and draw that line down the middle. So SB, our antimony here. This side I've got 2. This side I have 1. Oxygens, I have 3. Oxygens, I have 1. Carbons, 1. Carbon, 1. All right. So carbon looks good. So we don't really have to do anything with that yet. Antimony's not equal. Oxygen's not equal. Want to save those oxygens for last. So we'll look at the antimony. On our reactant side here, we have 2. On our product side, we only have 1. So let's change this to a 2. So now I have 2 antimonies on each side. But once again, oxygen's not equal now. So I have 3 oxygens on my reactants, 1 oxygen on my product. So what can I do for this? This isn't like the problem before where we have to change both of them. I can just change one. I'm going to put a 3 here. So now I have 3 oxygens. But what else do I have 3 of now? Carbon. Okay, so now my antimonies check out, equal, equal, oxygen, equal, equal, carbon, 1, carbon, 3. 3 right there will do the trick. And now we're equal and equal. So you can fill that in with a 1 if that makes you feel better. If not, leave it blank. So antimonies, 2, 2. Oxygens, 3, 3. Carbons, 3, 3. Everything checks out. We're good to go. All right, this one is a little bit harder. I'm going to let you try this one on your own. So pause the video. Before you do, one thing I want you to remember is count your nitrates as being nitrates the same on each side, because it's a nitrate and a nitrate that didn't separate. Count your sulfates as being the number of sulfates. So I will get you started on this. Not completely, but you can count it as this. Okay, instead of counting the nitrogens, counting the oxygens separately, counting the sulfurs separately, this will make it a little bit easier for you to balance. So go ahead, pause the video, come back, and check your answer. Alright, so here's the answer that you should have got for this balancing equation. So we have 2 aluminums, and then we also now have 6 nitrates, because remember, you're multiplying that by the 3 in the subscript. Okay? So 2 aluminums, 6 nitrates, 6 nitrates, 6 hydrogens, 3 sulfates, 3 sulfates. Alright, so something that is a little bit more difficult is writing the equations from the words. So this is going to use a lot of the stuff that you got in Unit 5 or Unit 4 with all of the naming. All of that's going to come into play now, okay? So you must use those correct naming rules. You must be able to identify, is this ionic? Is this covalent? Is this an acid? Is this a hydrate? What are my charges? Do they need to balance? Do I use prefixes? All of those things need to be things that you're thinking about constantly while you are naming equations. Okay, so there's these things called diatomic elements. So this prefix di here should make you think 2. So there are elements that are called diatomic that do not like to be alone. So what they're going to do is they're always going to pair up or they're going to twin up with themselves. So the diatomic elements are the Hofbrickels. You have to know these, okay? I will not tell you them. They will not be listed anywhere. You have to know the Hofbrickels. So hydrogen, oxygen, nitrogen, fluorine, bromine, iodine, chlorine. However you want to remember that, if you want to remember it as the Hofbrickels, if you can think of another way to remember it, that's fine. Just know that you have to know them. So what that looks like is going to be, you're never going to have a hydrogen like this. It's always going to be H2. You're never going to have an oxygen just by itself. You're always going to have O2. Same thing with your nitrogen, fluorine, bromine, iodine, chlorine. They're all going to pair up or twin up with themselves if they're ever alone. Okay, so you got to remember your Hofbrickels. All right, so let's go ahead and try and write out this equation first. Magnesium metal is dropped into a solution of sulfuric acid to produce magnesium sulfate and hydrogen gas. Okay, lots of stuff going on there. So let's kind of break it apart into things that so we can divide it. A key word here for us is to produce. So produce should make you think products. Products will make you think that right side of the equation, okay? So we're producing magnesium sulfate and hydrogen gas. So we know the two things that we are producing. So where do they come from? They come from magnesium metal is dropped into a solution of sulfuric acid. Okay. One way to do this is to write it out like this first. So we have magnesium metal plus sulfuric acid produces magnesium sulfate plus hydrogen gas. So first thing we got to do, magnesium metal, that's Mg. If it is a metal, then what state of matter is it going to be? It's going to be a solid. Okay? So remember, we have to include those in there. I'm going to write those in purple for now, just so we know. I'm going to leave a little bit of space here in case we need to balance. Is dropped into a solution of sulfuric acid. So sulfuric acid being H2SO4. And if it's a solution, remember I told you before, that means that it's aqueous. Produces magnesium sulfate, MgSO4. Magnesium sulfate is also aqueous. I should have included that in there. That's a solution. And we're adding that to hydrogen gas. Remember, hydrogen is a Hofbrickel, so we need 2 of those. And that is a gas. So there's our equation, but we can't stop there because we have to make sure that it is balanced as well, okay? So let's go through and let's count how many of everything we have. Magnesiums, I have 1. Magnesiums, I have 1. Hydrogens, I have 2. Hydrogen, I have 2. Sulfate stays the same on both sides. I have 1 on this side, and I have 1 on this side. So this is already balanced. So you can just throw 1s in front of there, or you can leave them blank. So easy one to start with, don't have to do any balancing. But what you would do after you got to that is you would start changing your coefficients, not changing your subscripts. All right, let's take a look at the next one. A solution of sodium chloride is added to a solution of silver nitrate to form a sodium nitrate solution in a silver chloride precipitate. All right, let's take a look at some of these words here. To form is another key or clue to you that we are producing the things following those words. So we're forming a sodium nitrate solution and a silver chloride precipitate. So that is our product 1, and that is our second product. So what are the reactants? Solution of sodium chloride, reactant 1, is added to a solution of silver nitrate, reactant number 2. I didn't say this before. Make sure that you are writing down the word problems as well, not just writing down what I write down at the end with the problem, okay? So feel free to pause these at any point. So reactant number 1 is a solution of sodium chloride. So sodium chloride being NaCl, solution that's going to be aqueous, plus a solution of silver nitrate, AgNO3, solution that's aqueous as well, forms a solution of sodium nitrate, NaNO3, both of those are +1 -1, plus silver chloride, that's AgCl. Precipitate, you saw this in another lecture. Precipitate means that it is a solid. This is also aqueous. So you're probably wondering, do these aqueous, solid, liquid? Yes, those count. Okay? You have to be able to read the problem and then apply that to what your state of matter is going to be. That's going to become very important in some future problems that we're going to do. All right, and then just by looking at this, we can tell this is already balanced. Sodium, we have 1. Chlorine, we have 1. Silver, there's 1. 1 nitrate, 1 nitrate. Okay, so already balanced there. All right, let's look at this one. When a solid aluminum oxide and hydrogen gas are heated, molten aluminum and water vapor are formed. So any of the problems we've seen before that formed or produced was kind of in the middle, and then we looked at what was after that. So now we have to go back and read. So the things that are formed were molten aluminum and water vapor. So that's product 1, that's product 2. So now looking at our reactants, when solid aluminum oxide and hydrogen gas are heated, so that's when the reaction is taking place, reactant 1, reactant 2. All right, so let's take a look at this, write these out. Aluminum oxide is Al2O3, that's an ionic, so you got to balance out those charges, plus hydrogen gas. Remember, hydrogen is a Hofbrickel, so I need 2 of them. Molten aluminum plus water vapor are formed. All right, what did I not do? I did not do my states of matter. So for the aluminum oxide, it tells us that it's solid. Hydrogen gas, that's a G. Molten aluminum, when you hear that word molten, you might be thinking lava, so we're going to call that a liquid. And then water vapor is not just water. Water vapor is steam, which is a gas. All right, so now we have to go through and balance this. I'm going to pause it at this point. I want you to practice balancing this on your own. Come back and see if you balanced it correctly. All right, so double check your coefficients. See if they match mine here. You should have 1 aluminum oxide plus 3 hydrogen gas. Yields 2 aluminums plus 3 water vapors. Remember that this does distribute all the way through to both your hydrogen and your oxygen. All right, one more. I'm going to have you try this one on your own. So how I want you to do this, go through, pick out your products and reactants, then come back. I'll have that done. Pause it again. I'll have the equation written out. Pause it again. I will have it balanced, okay? So After you've done one step, start it over. We'll come back. Make sure, because if you do the first step wrong, it's going to lead into mistakes in the next ones, okay? So go through, identify, come back and when you're done with that, and we'll make sure that you have everything correct in there. All right, so here's your division. When solid calcium hydroxide reacts with hydrochloric acid, so reacts is another way to saying they're combining. A solution of calcium chloride and water are formed. So your product 1 is calcium chloride, your product 2 is water. Okay, so pause this, write this out into formula form with your symbols. Don't balance it yet. We'll make sure that all that's set, and then we'll balance after that. Okay, so here's what your word form should look like. CaOH2. Now, when you're writing it out like this, and this goes back to how you're naming, remember that we're multiplying this whole hydroxide by 2. We're not just multiplying the oxygen. So if you wrote it like this, that is not the same as this, okay? So make sure that those parentheses are present, meaning that we're multiplying the entire thing by 2. Okay, and that is a solid. You are told that in the problem. Plus hydrochloric acid, which is a liquid, forms or produces calcium chloride, a solution of, which tells you it's aqueous, and water, which is a liquid. So now pause and then balance and come back. All right, so here's your balanced equation. 1 calcium hydroxide plus 2 hydrochloric acids yields 1 calcium chloride plus 2 waters. So that is the end of this video. A lot of this, it can be pretty overwhelming if you look at it all at once. Work on balancing first. Once you can balance, then make sure that you're able to write it into words and then do the balancing, okay? Use pencil because you are going to have to erase. It doesn't mean you're making mistakes. It's just kind of a trial and error type thing, okay? Good luck. Let me know if you have any questions.